Grounding requirements for surge suppression units are essential for protecting equipment from voltage surges. The National Electrical Code, specifically Section 250, covers grounding and bonding requirements. Section 250.4 addresses the grounding of electrical systems and circuits. Section 250.56 discusses equipment grounding conductors for ungrounded systems. Section 250.102d provides guidance on surge arresters. The Institute of Electrical and Electronics Engineers, or IEE, offers relevant standards. IEE Standard 1050 serves as a guide for surge voltage protectors. IEE Standard 1100 addresses surge voltages in low-voltage AC power circuits. Equipment grounding is paramount. The surge suppressor unit should be grounded to the equipment grounding conductor, or EG, of the electrical system. System grounding requires that the electrical system be grounded according to the applicable NEC requirements. This typically involves connecting the system ground to a bonded metal water pipe, ground rod, or other approved grounding electrode. If a lightning protection system is installed, the surge suppressor unit should be connected to the ground ring or another appropriate point in the system. Bonding is also crucial. All metal enclosures, including the fibux, should be bonded together and grounded. Several additional considerations apply. Firstly, the surge suppression device used in the unit should be rated for the maximum surge current and voltage expected in the installation. Secondly, the surge suppressor unit should be installed in a readily accessible location close to the equipment being protected. Thirdly, the unit should be clearly labeled to indicate its grounding requirements. The National Fire Protection Association, or NFPA, NEC website, IEE Surge Voltage Protectors website, and IEE Surge Voltages and Low Voltage AC Power Circuits website are valuable resources. When dealing with surge protection for sensitive equipment connected to remotely located radios and antennas, especially in areas prone to lightning strikes, proper grounding becomes paramount. Your primary focus is to protect indoor equipment from surges caused by nearby lightning. The surge suppressor unit must adequately handle the plus 5 volts direct current, plus or minus 12 volts direct current, and constant plus 12 volts direct current power supply voltages. The fibux weather-tight plastic enclosure provides environmental protection but does not inherently provide grounding. Determining and implementing the correct grounding strategy requires careful consideration of several factors and adherence to established codes and standards. The NEC is a cornerstone for electrical safety, and its Section 250 provides comprehensive guidelines on grounding and bonding. You should consult the latest edition of the NEC, specifically Section 250, to understand the requirements for grounding electrical systems and equipment. Pay close attention to Section 250.4a, which elaborates on the general requirements for grounding electrical systems and circuits to ensure safety and minimize the risk of electrical shock. Section 250.56, although titled Equipment Grounding Conductors for Ungrounded Systems, offers insights into grounding practices that can be adapted to your specific situation, particularly concerning the connection of equipment grounding conductors. Section 250.102d addresses the specifics of grounding surge arresters which are directly relevant to your surge suppressor design. This section outlines the conductor sizing and connection methods necessary for effective surge protection. Beyond the NEC, IEE standards provide valuable guidance on surge protection and grounding techniques. IEE Standard 1050 Guide for Surge Voltage Protectors offers detailed recommendations for selecting, installing, and grounding surge protection devices. This standard covers various aspects of surge protection, including grounding impedance, conductor length, and coordination with other protective devices. IEE Standard 1100, Recommended Practice for Powering and Grounding Electronic Equipment, provides best practices for grounding sensitive electronic equipment in commercial and industrial environments. While not solely focused on surge protection, this standard emphasizes the importance of a low-impedance ground path for minimizing noise and voltage transients. Now let's discuss the specific grounding requirements for your surge suppressor unit. Equipment grounding is the most critical aspect. The surge suppressor unit must be connected to the equipment grounding conductor or EC of the electrical system. The EGC provides a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to quickly clear the fault. Ensure that the EGC is properly sized according to the NEC tables, based on the rating of the overcurrent protective device protecting the circuit. The connection between the surge suppressor unit and the EGC should be as short and direct as possible to minimize impedance. Avoid creating ground loops, which can introduce noise and compromise the effectiveness of the surge protection. If the equipment being protected is powered from a separately derived system, such as a transformer or generator, the system must be grounded according to NEC requirements. This typically involves connecting the neutral point of the system to a grounding electrode, such as a ground rod or metal water pipe. The size of the grounding electrode conductor must comply with NEC tables. If a lightning protection system is already in place, integrate the surge suppressor unit with the existing grounding infrastructure. Connect the surge suppressor unit to the ground ring or other designated grounding point of the lightning protection system. This ensures that surge currents from lightning strikes are safely diverted to ground, minimizing the risk of damage to the protected equipment. Bonding is another essential aspect of grounding. All metal enclosures, including the Fibux enclosure, should be bonded together and grounded. Bonding creates an equipotential plane, which minimizes voltage differences between different parts of the system during a surge event. Use bonding jumpers to connect the metal enclosures to the EGC. Ensure that the bonding jumpers are properly sized and securely connected. Even though the Fibux enclosure is made of plastic, any metal components inside the enclosure, such as mounting brackets or connectors, should be bonded to the EGC. Several additional factors need to be taken into account for effective surge protection. Firstly, select a surge suppression device that is appropriately rated for the maximum surge current and voltage expected in the installation. Consider the lightning exposure of the location and the potential for other surge sources, such as switching transients or utility grid disturbances. The surge suppressor device should have a low clamping voltage to effectively limit the voltage seen by the protected equipment. Secondly, install the surge suppressor unit in a readily accessible location as close as possible to the equipment being protected. This minimizes the length of the conductors between the surge suppressor and the protected equipment, reducing impedance and improving surge protection performance. Avoid installing the surge suppressor unit in areas that are subject to excessive heat, moisture, or vibration, as these conditions can degrade its performance. Thirdly, clearly label the surge suppressor unit to indicate its grounding requirements. This helps ensure that future maintenance or modifications are performed correctly. The labeling should include information about the grounding electrode connection, the bonding requirements, and the recommended inspection and testing procedures. Always refer to the manufacturer's instructions for specific grounding recommendations for the surge suppressor device. The manufacturer's instructions may provide additional details on grounding methods, conductor sizing, and other installation considerations. In addition to the NEC and IEE standards, consult local electrical codes and regulations for any specific grounding requirements that may apply in your jurisdiction. Local codes may have more stringent requirements or additional provisions that are not covered in the national codes. Finally, regularly inspect and test the surge suppressor unit to ensure that it is functioning properly. Check the grounding connections for corrosion or looseness. Use a surge tester to verify the clamping voltage and surge current capacity of the surge suppressor device. Replace the surge suppressor unit if it shows signs of damage or degradation. Understanding and implementing these grounding requirements is crucial for protecting your equipment from voltage surges. By following the guidelines in the NEC, IEE standards, and manufacturer's instructions, you can ensure that your surge suppressor unit is properly grounded and bonded, providing effective protection against lightning strikes and other surge events. Remember that proper grounding is not a one-time task, but an ongoing process that requires regular inspection and maintenance. Now let us consider the importance of equipotential bonding in mitigating surge effects. Equipotential bonding ensures that all metallic parts within a system are at the same electrical potential, minimizing voltage differences and preventing dangerous circulating currents during a surge event. This is particularly important in systems with sensitive electronic equipment, such as your radio and antenna setup. Firstly, connect all metallic enclosures, conduits, and cable trays to a common grounding point using appropriately sized bonding conductors. These conductors should be as short and direct as possible to minimize impedance. Use bonding clamps and connectors that are listed for grounding purposes to ensure a reliable connection. Secondly, bond all metallic components within the Fibux enclosure, including mounting brackets, connectors, and any other metal parts to the enclosure's grounding point. This prevents voltage differences from developing between these components during a surge. Thirdly, if your system includes multiple interconnected buildings or structures, implement inter-system bonding to ensure that all grounding systems are interconnected. This can be achieved by installing a bonding conductor between the grounding electrodes of each building. Now let's delve into the selection criteria for surge protection devices, or SPDs, suitable for your application. Firstly, choose SPD with appropriate voltage and current ratings for your system. The SPD maximum continuous operating voltage, or MACOV, should be higher than the nominal voltage of your power supply to prevent premature failure. The SPD surge current rating should be sufficient to handle the expected surge currents in your environment. Secondly, select SPD with a low voltage protection level, or VPR. The VPR is the maximum voltage that the SPD will allow to pass through to the protected equipment during a surge event. Choose SPD with a VPR that is below the voltage withstand capability of your sensitive electronic equipment. Thirdly, consider the SPD response time. The SPD should respond quickly to surge events to prevent damage to the protected equipment. Choose SPD with a fast response time, typically measured in nanoseconds. Now let's discuss the practical considerations for installing your surge protection system. Firstly, locate the SPD as close as possible to the equipment being protected. This minimizes the length of the conductors between the SPD and the equipment, reducing impedance and improving surge protection effectiveness. Secondly, use short, straight conductors to connect the SPD to the grounding system. Avoid sharp bends or loops in the conductors, as these can increase impedance. Thirdly, ensure that the SPD are properly grounded to a lower impedance grounding system. Connect the SPD to a dedicated grounding electrode or to the building's main grounding electrode. Let's explore maintenance and testing procedures for your surge protection system. Firstly, visually inspect the SPD regularly for signs of damage or degradation. Look for cracks, bulges, or discoloration in the SPD housing. Secondly, test the SPD periodically to verify their functionality. Use a surge tester to simulate surge events and measure the SPD clamping voltage. Thirdly, replace SPD that have been damaged or have exceeded their surge current capacity. SPD have a limited lifespan and will eventually need to be replaced. Let's elaborate on lightning protection system integration. If your facility has a lightning protection system, integrate your surge protection system with the existing lightning protection system. Connect the SPD to the lightning protection system's grounding network to provide a comprehensive surge protection solution. This ensures that surge currents from lightning strikes are safely diverted to ground, minimizing the risk of damage to your equipment. If you're dealing with sensitive data lines, ensure they are adequately protected. Protect data lines using dedicated data line surge protectors. These protectors are designed to clamp voltage surges on data lines, preventing damage to connected equipment. Select data line surge protectors that are compatible with the type of data lines being protected, such as Ethernet, serial, or coaxial cables. When it comes to plastic enclosures, grounding can be a bit tricky. Although the Fibux enclosure is made of plastic, it's still essential to ground any metal components inside the enclosure. Bond these metal components to a common grounding point and connect that point to the equipment grounding conductor. This prevents voltage differences from developing between the metal components during a surge. When installing wiring, it's crucial to maintain proper separation between power and data cables. Route power and data cables separately to minimize electromagnetic interference, or EMI. Use shielded cables for data lines to further reduce EMI. Separate grounding conductors from signal conductors to prevent noise from being coupled into the signal lines. Finally, remember the importance of documentation. Document your surge protection system, including the location of SPD, the type of SPD used, and the grounding connections. This documentation will be helpful for future maintenance and troubleshooting. Keep records of all inspections, tests, and replacements performed on the surge protection system.